AI is about making computers intelligent. The field of AI contains many different subdomains. After all, there are many ways to define intelligence and many more ways to achieve this. Some commonly named subdomains of AI are natural language processing, machine learning, neural networks, computer vision, planning, search, knowledge representation, reinforcement learning, etc. If you look at this list, you might notice that these terms don't all describe the same thing. Specifically, some describe what we wish to achieve, such as computer vision. Others describe techniques, such as reinforcement learning. In this video, we'll take a closer look at the distinction between outcomes and techniques in order to help understand the different types of subdomains in AI. Artificial intelligence aims to make computers smart, either by making them think or behave like humans, or making them think or behave rationally. Intelligent thinking or behavior can comprise of many different things. For instance, planning, reasoning, and learning, but also seeing and speaking. Some subfields in AI are specified by what intelligent behavior or thinking they are trying to achieve. Some of these are about how we perceive our environment, such as computer vision, which tries to make computers see and understand their surroundings. Some are about communication, such as natural language processing or NLP, which attempts to make computers process human language. Some are about cognitive processes, such as planning, trying to make computers break down and plan a task, or learning, which is about making computers learn by themselves. And as AI advances, some are about increasingly complex behaviors, such as negotiation, recommendation, or social signal processing. What relates these fields to each other is that they are not defined by how a certain process is achieved, but rather by what the computer needs to do. On the other hand, there are techniques. Techniques are groups of approaches and algorithms which can be used to achieve some of these behaviors just described. Very broadly speaking, most techniques within AI follow either a symbolic or a sub-symbolic approach. For instance, logic is often used as a symbolic approach and mathematics as a sub-symbolic approach. You can also classify a centralized and decentralized approach. In centralized AI, there is one main agent in which all the components of a behavior come together. In decentralized AI, however, the intelligence emerges from individual agents which interact, such as a multi-agent system. A very basic example of a goal for such an approach is swarm behavior, where individual agents, for instance drones, each have simple rules for how they interact with each other and their environment, eventually creating more complex behavior patterns. To take another look at this distinction between outcomes and techniques, let's look at machine learning. Machine learning is at its core the goal of making computer systems learn, either fully by themselves or with a little help. Learning is an outcome, which can contribute to the overall goal of AI to think or act intelligently. With machine learning, you can discover smaller goals, such as classification, the goal of learning to classify something into a group, or prediction, to learn how to predict a value from previous knowledge. With a lot of these possible goals related to learning, you have different techniques to achieve them. For instance, you can use decision trees, k-nearest neighbors, or neural networks to teach your computer to classify something based on past data. These are all very different types of algorithms or techniques, but they can be used for a similar task. Within machine learning, we often talk about supervised, unsupervised, or reinforcement learning. And very basically, these define whether you learn based on examples, without examples, or based on trial and error. These labels specify something about the types of techniques used to learn. And some techniques are more suitable to achieve specific goals, but other techniques can be used for many different things. People working towards different goals might sometimes be using similar techniques, although machine learning in itself is more like a goal to make the computer learn. The term is also often used to describe the collection of techniques which can be used to achieve this goal. For instance, when someone says they're using machine learning to recognize emotion from faces. In this case, the overall goal isn't really learning, but rather emotion recognition. The technique used is one which uses learning, making the computer gain knowledge by itself to achieve this goal. Most probably, they mean they're using a specific machine learning technique, such as a neural network, to achieve this goal. When someone is studying how to make a computer learn better, they're typically working in the field of machine learning and in AI. And when someone is studying how to use learning algorithms to achieve another goal, for instance, to predict water flows in a river based on weather data, they're typically using machine learning techniques in another field of study. To conclude this video, we talked about the difference between outcomes and techniques in artificial intelligence. Outcomes are the intelligent behavior and cognitive processes which AI tries to recreate in a computer, such as language, vision, learning, planning, etc. Techniques are the methods used to do this, such as logic-based or mathematic-based models. And as an example, learning is a goal, but a neural network is a technique. Often we say that researchers who work on AI outcomes say they are working in AI, where researchers using typical AI techniques for other domains are working with AI.